So we're going to be looking at hybridization. Before we do, I want to go ahead and review a couple things just so we can get familiarized with it. So take, for example, this structure right here that's highlighted underneath in green. You have the carbon and that oxygen. And yes, it is a double bond. Yes, it is an alkene. However, I want you to know that one bond. So let's say, let me highlight this one. So if there was one bond between the carbon and the oxygen, that would be known as a sigma bond. Any bonds that are extra are known as pi bonds. So with that out of the way, now that you know sigma and pi, the type of bond between this carbon and this oxygen makes it so it doesn't rotate freely. So it doesn't experience free rotation. Now, this structure underneath here, you have a carbon bonded to another carbon that is, as opposed to the pi bond on the structure above, this one is just a single bond, also known as a sigma, right? This experiences free rotation. So sigma bonds experience free rotation at room temperature, which means they can kind of rotate freely. Now this is going to help us with hybridization. So now let's look at these structures right here. We have a carbon with 4 bonds. All that you have to do is that you have a carbon atom with 4 single bonds. So then it would be how many pi bonds? Each single bond is 1 pi bond. So, each single bond is a sigma. So it would be 4 sigma, right? Sigma bonds. And that corresponds with sp3 hybridization. So let's say you count them, right? It's 1, 2, 3, 4. You just knock it down 1 and you make it sp3. So with this one, a carbon that has 3 bonds. So this is a carbon with 3 bonds. And one of the bonds is pi. This is going to correspond to 2, which means that this double bond here counts as one bond. A double bond will count as 1 bond. So then this would make it 1, 2, 3. Take it down a notch. So we have sp2 hybridization. Alright, so finally a carbon atom with 2 sigma bonds and 2 pi bonds will be sp hybridization, such as this case. This whole thing of triple will count as 1, and this single bond will count as 2. You knock it down 1, that makes it sp hybridization. Alright. So now that we got that covered, let's go ahead and take a look at this structure and try to figure out all the hybridizations on the carbon atoms. And let's see if we can figure out just by looking at them, right? Well, initially if you want to count, that's fine. But let's look at all of this. So this carbon has how many things surrounding it? 1, 2, 3, 4. Knock it down 1. So this carbon and sp3. How about this carbon? The same thing. However, that's right. However, though, I want you to notice that the carbon next to it, so this carbon, now it has a double bond next to another carbon, has a single bond and another single bond. The double bond, we said it would count as 1. So this is 1, 2, 3. We knock it down 1. This would be sp2. Okay? So we know that this carbon is the same as this carbon because it's a carbon that has a double bond and 2 other single bonds. So it would be, this counts as 1, this counts as 1, and then this counts as 1. You knock it down 1, so these 2 carbons are sp2. We go to the carbon at the following carbon, and now you could just look at them, and you know that you see 4 single bonds. Knock it down 1, you know that's going to be an sp3 for this carbon. Now, this carbon we talked about A triple bond still counts as 1, and it's attached to another bond that counts as 2, so this carbon is sp. This carbon is the same as the other carbon. This carbon is the same as the other carbon, so that one's sp as well. All right. So you can try to do these. You can try to do these and then double check with me to see if you got these right. So let's just focus on this carbon here, the first carbon. What is a hybridization? Again, you can just eyeball it and know that it's attached to 4 things. We'll put down one. This carbon is sp3. Now, let's look at this structure. We want to focus on this carbon, and this carbon. What would be the hybridization? Again, these are pretty easy because they have 4 single bonds, and those 4 single bonds, 2 carbon corresponds to sp3. So all of these are sp3. Okay, so now let's take a look at this structure. And I want to look at this and this carbon. And actually, we're missing a bond here. I want you to see that you could just quickly look at these and identify them without having to label each bond, because you can just see that it's sp3. Okay, so allocate more sp3. Where are the sp3 carbons in this structure? Are there any of them? No, we don't have that. So let's take a look at each individual carbon in here. We know that the double bond, this double bond here, corresponds to 1. So this would be 1, 2, and 3. So this carbon is going to be sp2. We can look at the structure and identify that this carbon is the same as the carbon at the end. So this one is going to be sp2 as well. The 2 carbons in the center are exactly the same. So if this carbon is bonded to a double bond and another double bond, this is going to count as 1. This is going to count as 1. And so this would make these 2 carbons sp hybridization. And that's pretty much how you do hybridization. Pretty simple.